This is Professor P.K. Giri from Nanotechnology Center. So we have been working on various nanomaterials and more recently on two-dimensional semiconducting materials for various sensing applications. And in this particular work, we have actually explored one new semiconducting two-dimensional material, which is palladium di-selenide, which has got very fascinating property. It changes its from metallic property to semiconducting when it goes to ultra thin layer, about 1 angstrom thickness. And we are exploiting many other 2D material, but this particular material draws our attention for its anisotropic property, and defects also give rise to some interesting behavior where you can see both metallic as well as semiconducting behavior in the same material. It's a micro Raman spectroscopy setup. This is a commercial setup which we have used for our research, and Raman spectrometers are very useful for various kind of applications, and usually the Raman signal is very weak, so we cannot detect extremely low concentration of analytes. In this case, we have actually detected ultra low concentration of toxic dyes which are harmful for chemical, which are produced by the industry. And here you see this is a microscope part, and this whole big system is actually a Raman spectrometer, which can give you some signal for particular molecule. There will be certain peaks, and that are characteristic of that molecule. In this case, we have usually Raman signal is very weak, so one technique which has been used for about last 20 years is called surface enhanced Raman spectroscopy, where people use metallic nanostructures as a substrate, and on that they put the analyte to detect Raman signal, measurable signal. But usually these metals are noble metals and they are expensive, and they have also like stability issues, biocompatibility. So people are looking for alternatives for this surface enhanced Raman spectroscopy substrate. So in the research for alternatives, we have found one interesting new semiconducting material, which is ultra thin palladium di-selenide, and we have engineered the material to act as a very good search substrate, and using this we have been able to detect various kind of toxic dyes at ultra low concentration at the nanomolar level.
Hello, I am Tadasa Jena. I am working in Center for Nanotechnology in Nanofabrication Lab. I am in 4th year and I am working under Professor P.K. Giri. Let me explain to you the structure of PDSA2. Palladium diselenide is a metallic material in ball form, but when we go to the 2 layer or 1 layer, then it will be behaving like a semiconductor. And this is the 2 selenium atoms of the palladium diselenide, and this is the 2 below selenium atoms of the palladium diselenide, and these selenium atoms are connecting with a PD in between, that is dumbbell-like structure of PDSA2, and this is the anisotropic structure actually, as the plane is not in one plane. This is like stepping of it.
We have also plans to exploit in many other applications, including biosensing and gas sensing and photodetector applications.